Okay, in this video I'm going to show you some of the ways that this works. Like I'm going to try and explain how the counting electronically works, and if I show you what most of the knobs are for, it'll help you in troubleshooting. Sometimes you're not getting what you want. So let's go. This is the photo detector. The signal from the photo detector goes into the amplifier. It gets amplified, and then we can monitor it through this blue cable. If I block off the photo detector, see, the line rises. So high is dark, low is bright. So when I turn on the motor to do Michelson interferometry, look, I'm going a very small amount. Hold on, let's amplify that a little bit through here. Let's amplify it a little bit through here. Oh yeah, sorry. There's nothing happening. You can see that the line is rising, but there's nothing happening. Why is there anything happening? It's because the counter only counts when the voltage goes from positive to negative. But this is going from something negative to a little more negative. So it's as though it's going from -2 to -3 to -2 to -3. What we need it to be doing is going from +0.5, -0.5, +0.5 to -0.5. And we have a DC offset. So let's do a DC offset and see if we can... Oh, no. There, now we're counting because we added a DC offset to it. And actually, let's see what oh, look at this. Why did that get bigger? That got bigger because I turned this knob. What this knob does is it says, only look at changes in voltage that happen slower than 0.1 of a second, or 10 milliseconds, or 1 millisecond. So let's see what would happen if I was to turn this to minutes. Well, look at this. I'm getting a crazy high reading. I'm getting a crazy high reading because I'm saying, look at the voltage real fast as a function of time. And look at this. It's going really high and it's giving me... I can make the mirror vibrate, watch. Look, it's vibrating, it's catching it all, and now it's slowing down. This is no good. I don't want it to be so sensitive. I only want it to respond to like 1/10 of a second. Now look at that, that's lovely. However, this setting here, I'm going to tighten it up a little bit. If I go back to this setting where I'm looking at the whole voltage, this is nice because now I can see where the zero line is. Let's ground the oscilloscope, and we're going to make the zero the middle. Now that's where zero is. Now if I tap this, I get, as long as it goes from negative to positive to negative, I get a count. We can reset that to make it look nicer. Now watch what the DC offset does. Look, I'm not getting anything. No counts. Loads of counts because I'm crossing the zero line. And now no counts again. So that's how you figure out, maybe you're getting no counts, that can be the reason. I'm going to tell you why this thing counts the way it does. It turns out it's not hard to buy off-the-shelf chips. They're called counters, and they do the following thing. When the voltage goes from negative to positive, nothing happens, but in positive to negative, they count 1, 2, 3, 4. Let's see what's going on here. Okay. When this goes, I'll make it look even a little more. We can actually turn the motor off, and we can count by flexing the table. Negative, positive, 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 positive. Every time I went from negative to positive, this counted, but when I went from positive to negative, it didn't. Let's see it again. It's negative, positive, positive, negative to positive, negative to positive, negative to positive, negative. See? It's very nice. It's not hard to make computer logic to do this. So, troubleshooting. Turn the time scale down to nothing so you can see all the vibrations. Voila. Turn it back to 0.1. Make sure the DC offset is where it should be, so that this side is crossing 0. This is the DC offset, and that'll cover most of it. Make sure you're on channel count. That should cover most of your troubles. Okay, goodbye.